Hi guys, I'm Nivita. In this video, we are going to see one problem based on CSIR NET exam. Okay, this question has been asked in CSIR NET June 2016. So let V is a function from closed interval 0, 1 to R. F is a polynomial of degree less than or equal to n. Here F is a function. Okay, so from closed interval 0, 1 to R, real numbers. So f is a polynomial of degree less than or equal to n. Okay, fj of x is equal to x power j. Okay, what they have given is fj of x. If you operate x by a function, it goes to x power j. For 0 less than or equal to j less than or equal to n, j lies in the interval of 0 to n. Let A be n plus 1 by n plus 1 matrix. Okay, the order of the matrix is n plus 1 matrix. Given by Aij. Each element of the matrix is defined by an operation which is integral over 0 to 1 fi of x into fj of x dx. Then which of the following is true? Dimension of V is equal to n. Dimension of V is greater than n. A is non-negative definite for all values of V belongs to R power n. Inner product of AV comma V is greater or equal to 0. Determinant of A is greater than 0. Okay. So what I'm going to do is I'm going to take the order as n as 2. Okay. So if you take n means it's like the matrix will form like 3 by 3 matrix. Okay, so that's why I'm taking the value of n as 2. I'm taking the value 0 less than or equal to j they have given, right? So I'm taking the value of j as 0. Okay, I'm taking the value of j as 0. See here, f0. Okay, instead of a j, I'm going to put, because j value is equal to 0, right? So instead of j, I'm going to put f0 of x is equal to x power 0. X power 0 is 1. Okay, f1 of x, f1 of x, f power 1 of x, 1 of x means x. Okay, so j, if you put 2 means okay, basically we are taking the value of n as 2. So j also equal to 2, right? So when you substitute 2, f2 of x is equal to x power 2 will come. Okay, now I'm going to find each element of the matrix Aij. So suppose you are using like A00 where so why I am putting this means they are going to consider the value of the matrix as A00, A01, A02. Okay, next A10, A11, A12. Next A20, A21, A22. Okay, so A00 means here you have to put is the integral over 0 to 1. Okay, so what we are using is, so for fi of x also they are using the same as fj of x. We have found out, right? So if you substitute the same value means what you are going to get is, instead of fi of x, fj of x, you have to put, for it is like 0 0, right? So 0 0 means x power 0 will give you 1, which is dx is equal to, if you integrate 1 means integral and differentiation cancel. So x 0 to 1 will come, 1 minus 0 will give you 1. Suppose if you take f0 1 means you have to put like f0 of x into f1 of x. f0 of x will give you 1. f1 of x will give you x. Okay, so we have to integrate for x. If you integrate x means you will get x square by 2. So the limits is 0 comma 1. So if you substitute 1, you will get 1 by 2. Then A02 means it will give you like 0 and here it is 2. Okay, so f0 of x will give you 1 into f2 of x will give you x square. So it will give us x cube by 3. So if you substitute 1 and 0, you will get it as 1 by 3. Then you are going to substitute for a10. a10 means what? A10 means here you have to take it as 1 and here you have to take it as 0. So f1 of x will give you x and f0 of x will give you 1. So if you integrate, you will get x square by 2. So the value is 1 by 2. Same like a11. a11 means here also 1, here also 1. f1 of x will give you x. So x into x is x x square. So if you integrate, you will get x cube by 3. You may ask, like, normally we used to take the matrix as a11, a12, a22. Sorry. Normally we used to take it as a11, a12, a13, a21, a22, a23. But why we are considering you can ask, like, why we are considering a00, a01, a02, like that. Here what we are going to do is, here they have given the j value coming from 0, not starting from 1. Okay, yeah. So that's why we are taking as a00. Understood? a01, a02. Actually it is of n plus 1 by n plus 1 matrix, so it is 3 by 3 matrix. So they are using like a00, okay, then a01, a02, then a10, a11, a12, a20, a21, a22. Understood? So you have to consider a matrix like this. That is a twist here. So normally we used to consider a matrix like this only, right? So but here what they have given the value of j starting from 0. So we have to consider everything in terms of 0. Okay, so like that we are finding the value of the matrix and we are just substituting. Okay, fine. So we will go to the options. Here what they have given is dimension of V determinant is greater than 0, likewise they are asking. So first here before that they have given like definite, about definite they have given, right? So we will find a11. Okay, a11 is this value. Okay, so the value is greater than 1. a22 means you have to consider this two rows and 2 columns. So what you will get, 1 by 3 minus 1 by 4 will give you 1 by 2, which is greater than 0. a33 means the total 3 by 3 matrix. Okay, a11 means single element, a22 means 2 by 2 matrix, a33 means 3 by 3 matrix. You will get the value which is greater than 0. So a11 is greater than 0, a22 is greater than 0, a33 is greater than 0. So definitely it is a non-negative definite. And the determinants means if you consider this value, it is a determinant, right, which is not equal to 0, right? So here option D will come. Okay, option C will come, non-negative definite. Then here the dimension of V is 3 greater than 2. So actually the dimension is the value of n. Okay, so which is 3. Actually you are considering the value of n as 2, right? So here the dimension you are getting the value as, here the determinant of a not equal to 0, right? So which means it is this 3 rows or independent matrix. So therefore the dimension of V will be equal to 3, which is greater than 2. Therefore the dimension of V is greater than n would be one answer. Okay, thank you for watching. If you like this video, please like, share and subscribe to my channel. Thank you.